everyone. So today we're going to learn how derivatives affect the shape of a graph. Okay, so now so if f prime changes from positive to negative at C, then f has a local maximum at C. Okay, and if f prime changes from negative to positive at C, then f has a local minimum at C. If f prime does not change sign, there is no local maximum or minimum at C. I know it's hard to understand in a written form. We have to do the example first, right? Okay, and the second derivative test is let me write it down for you here. If f double prime C, which means f double prime is you derive it 2 times, larger than 0, then local is at C, and this one is f double prime critical number is less than 0, then local maximum is at C. Okay, now let's look at example 9.2. Example 9.2, where fx is 6x squared minus x cubed. Okay, now we want to find the critical number for this equation. How to find the critical number is we make this equation to be equal to 0. Okay, but first you have to differentiate it. Okay, so there will be 12x minus 3x squared equal to 0. Put the 3x together, you will get this. Okay, so x is equal to 0 and x is equal to 4. So 0 and 4 is the critical number for this particular function. Okay, now that's settled. So if f double prime critical number is larger than 0, then f has a local minimum at C. And if f double prime critical number less than 0, then f has a local maximum at C. Okay, now we want to look. Okay, so f double prime is, we differentiate again this equation here. So you will get 12 minus 6x. Okay, and you slot in 0 into f double prime, you will get 12, which will be 12 is larger than 0. So if larger than 0, it is, then f at x equal to 0 is local minimum. Okay, now we put in 4 and see, you will get minus 12. Minus 12 is less than 0. If less than 0, so x equal to 4 is local maximum. Okay, So now we have determined whether x equal to 0 or x equal to 4 is local minimum or local maximum. Now we want to find the value when okay, I'm gonna write this down. Local minimum at x equal to 0. Okay. Okay, in the original equation, put in the value 0. 0, 0, you will get 0. Okay. And then we want to find the value when local maximum at x equal to 4. So put in 4 here. You will get is minus 32. Okay. Okay, so now moving on to the next slide. Okay. Example 10 wants us to find the local maxima and local minima of fx using both tests. The first, what is both tests? This is the first test and this is the second test. Okay, so now let's do, for this one, I'm going to do the first test. And this one, we're going to try the second test. And I want you to try to, on your own, how to solve this using second test. And this using the first test. Try at home and compare the results. Okay. So now example 10a is okay, now we are using the first derivative test. So first step is to derive this function, which should be 12x cubed minus 12x squared. Put the 12x together, equal it to 0, and then you will get x equal to 0 and x equal to 1. So x equal to 0 and x equal to 1 is the critical number. Okay, now we want to do the line test. Remember in a previous lecture, I have teach you how to do the line test. So critical number is between 0 and 1. And the equation that we should use is this is 12x squared. Okay. So it should be x squared and x minus 1. Where we will get it? We get it from this part here. X squared and x minus 1. I just omit the 12 because it will be equal to 0 either way. Okay. So now pick any number less than 0. Okay. Any number less than 0. Okay. I want to pick minus 1. So minus 1. X squared minus 1 square is 1. So positive. And x minus 1 equal to minus 1 minus 1. You will get minus 2. So negative. And then positive times with negative, you will get negative. Okay. Now in between 0 to 1, I want to pick the value of 0.2. Okay, so x squared 0.2 square is 2.4 and x minus 1 is 0.2 minus 1 is minus 0.8. So this one is positive and this one is negative. Again, positive times with negative, you will get negative. Okay, and then the final one here, pick any number larger than 1. So I want to pick 1.2. So 1.2 is x square. 1.2 square is 2.4. And x minus 1. 1.2 minus 1, you will also get, okay, both numbers are positive. So this one is positive. Okay. So there is no local maximum or local minimum at x equal to 0 because the shape remains the same. What shape? What shape? What shape? This shape. Okay, let me show you. Okay. When the value is negative, it is decreasing from less than 0, and then again it is decreasing from 0 to 1. Only from 1 to infinity it is increasing. Okay, so that's what I mean. There is no local minimum or maximum at x equal to 0 because the shapes remain the same, which is it remains decreasing. Okay, so now is at x equal to 1, and then we want to find the value when f is equal to 1. It is minus 1. Okay, and then there is no local maximum. So the interval of increasing is from, okay, increasing from where? From 1 to infinity. And interval of decreasing is from minus infinity to 0 and from 0 to 1. Okay, so this is the final answer for question example 10a. Okay, I have to stop now, and I'm going to continue next time. Okay, see you guys, bye.